Hello and welcome to our video on reactions involving esters. Today we'll be covering two of the very common reactions that esters are involved in, and then also I'll be giving you a brief introduction into saponification and what it is. So with regards to the reactions that an ester can undergo, they're both hydrolysis reactions. However, the products vary depending on if the hydrolysis reaction is conducted in an acidic or an alkaline environment. Recall that the hydrolysis reactions are essentially the reverse of condensation reactions. So in a hydrolysis reaction, a large molecule, in this case an ester, is broken down into two smaller molecules and a water is consumed in this process. If it's in an acidic environment, these two products that we make are the original alcohol and the original carboxylic acid. So water is also consumed when we're doing this procedure. So water is one of the initial reactants, and we usually need sulfuric acid, so concentrated sulfuric acid as a dehydrating agent, and a lot of heat to do so. So that's a hydrolysis of an ester in an acidic environment. It forms the original carboxylic acid and the original alcohol that the ester is made up of. So essentially the reverse of esterification. Hydrolysis of the ester in an alkaline environment is slightly different. So the same principle applies. So hydrolysis being the opposite of condensation, you use the larger molecule, the ester, to form two products, which is, in this case, you get the alcohol again, but in this time, instead of the carboxylic acid or the original carboxylic acid, you make a carboxylate anion. So these are a special class of compounds. You might not have seen them yet, but essentially this is an example of the carboxylate anion. It's essentially the carboxylic acid without a terminal hydrogen group on one of the oxygens. So there's no OH group, it's just an O- instead of the OH group at the very end. The naming system is something we need to discuss. It's named very similarly to how carboxylic acids are named. So if this had a hydrogen at the end, this would be ethanoic acid. However, since it's a carboxylate anion, we call it the ethanoate ion. So this prefix, the O8 ion, is kind of applicable for all of your carboxylate ions, and you just count the number of carbons. So in this case, there's 2 carbons, so it's an ethanoate ion. Another way of thinking about this is that it's the conjugate base of the carboxylic acid. So that's another way you can think about it. So recall that the conjugate base is the acid with minus hydrogen group, which is essentially what this carboxylate anion is. This reaction, so hydrolysis in an alkaline environment of an ester, is essentially what you're going to be doing in saponification. We do have a separate video on saponification in general, but to give you a brief introduction onto the topic of soaps, it's important to understand that they are essentially a metal salt. So if you look at I have a right-hand side, I have a diagram of a soap, just a common soap. We have this really long hydrophobic group, which is a large alkyl chain. If I change colors, you can also see this functional group here, which you may draw similarities to this functional group here. So essentially, this soap is just a carboxylate ion with a very long alkyl chain. It's also got bonded with this sodium cation. So essentially, soaps are just metal salts of these long chain carboxylate ions. Saponification is the process by which we would make a soap. So essentially, we use triglycerides, which are large esters, and we take them through a hydrolysis in an alkaline environment to make these soaps. That's all you need to know at this stage. We do have an in-depth video covering saponification in general, and in the next slide, I'll show you an example of a hydrolysis reaction in an alkaline environment. So this is that example of the hydrolysis in an alkaline environment, and essentially we have our original carboxylic acid. If in an alkaline environment, so I'm going to say sodium hydroxide, again, this is a hydrolysis reaction, so we are going to consume water, so water is going to be on the left-hand side of the arrow. However, instead of sulfuric acid, we have sodium hydroxide, so it's in an alkaline environment. In this case, it's going to form our carboxylate ion and the original alcohol.